All right, everyone, we've come to our time, the last problem set solution. So we're trying to examine electrochemical properties of these materials. C solution, 400K. Employees give me the table to measure cell voltages. So let's go ahead and we're going to open up our PowerPoint. So we need, before I do that, this will be very helpful. So I need to find PT equals CD equals CO equals NI equals, put this here too. What else do we need? NI ZN equals SN equals MG equals, I already have CO, I already have CD, I already have NI. So let's go ahead. Let's look up our standard values in the table. So PT 1.2. So if I can just go down exactly. CD is going to be minus 0.403. Let's go down. CO is going to be minus 0.277. Go down. Nickel is going to be minus 0.25. Zinc is going to be zinc. Where are you? Minus 0.763. Tin SN is going to be equal to minus 0.136, and then Mg is going to be equal to what? Minus 0.2363. Oh, minus 2.363. Excellent. So positive terminal, negative terminal. So we know it's just going to be PT minus CD. It's going to be CO minus NI. These are all the E naughts. ZN minus SN, Mg minus CO, CD minus NI. So what you'd expect, right? If we have a positive voltage, if the electrons flow from negative terminal to positive terminal, PT should not corrode. So we see the electrons are flowing, and that seems to kind of make sense with our intuition. Which materials the anode cathode in each cell listed? So in the non-standard conditions, so I'm going to say for the anode, I'm going to circle. And then cathode, for the cathode, I'm going to circle, Cathode, I'm going to circle. So here we're gaining electrons. Here, this is where we're gaining electrons. This is where we're gaining electrons. This is where we're gaining electrons. And that's just from electron flow, which is just the sign of the voltage that we got. We've already filled out the standard conditions. Standard conditions. Temperature equals 298 K. Pressure equals 1 atm, and we're in a 1 molar solution of each ion. Which materials will undergo oxidation? The material that is not circled, so the one that's not circled. Which ones will electroplate? The one that is circled up there in the non-standard conditions. Calculate E naught. So we got that. What's the ratio of cathode to anode ions for CD and Ni? So remember, CD, Ni, we're going to use our Nernst equations, E minus E naught. If we were to write out this full cell, basically the full cell reaction here, we'd have CD, basically that's gaining electrons. So in the solution, CD 2 plus 2E minus goes to CD. And then on the other side, it'd be nickel is going to, and nickel 2 plus 2E minus. So the full cell reaction will be CD 2 plus Ni goes to CD plus Ni 2 plus, meaning concentration of products, which is Ni, which is our anode over our cathode, which would be CD. So the ratio of cathode to anode ions would be the inverse of that. We can solve that for this problem. So for example, for the Nernst equation, log of, basically we want 1 over x, because we want the ratio of cathode to anode, not anode to cathode, which would be, ratio of cathode, the vice versa, for this problem. Temperature is equal to 400, set at the outset of the problem. And then our E naught is just CD minus Ni. And we actually see here, that's what it should be doing, but again, the E that we are measuring is a 1.2 volts. And then finally, I'm just going to assume 2 moles. So NEQ, and then let's solve for NEQ. I don't want to solve for x. I'm going to solve for the ratio just x, and then I'm going to flip it. And I'm just going to do the inverse of that. 1 divided by. There we go. That's it. So that is problem set 8. It's been a pleasure to have you all in the class, and I'll see you another time. Thanks. Bye.